So next up is going to be Sridhar Sistu. He's the Vice President of AI Offers at Schneider Electric. He's a senior software project executive and leader with extensive experience in product strategy, portfolio planning, sales enablement, cloud architecture, DevOps, large-scale deployments, offshore management, and project management. He's currently working on accelerating AI adoption and technology offers to optimize energy usage and improve sustainability at scale. He's also going to be a judge at our poster competition tonight, and Schneider's been kind enough to join us as a sponsor for that poster competition. So now we're going to play a short video introducing their company.
The energy transition is here. And it's evolving, accelerating. Demand is booming, supply is finite, costs are rising. Time feels more precious than ever. Because our generation is the first to feel the effects of our changing climate and may be the last that can make an impact. From utility rooms to operating rooms to dining rooms, there are limitless possibilities to reduce energy waste, to realize net zero, and to emerge more resilient. Digital and electric are the formula for a more sustainable world. So this moment is our moment. The moment to lead, the moment for opportunity, the moment for action. The greatest movements are sparked by bringing things together, ideas, leaders, technology. Let's empower everyone to make the most of our energy and resources, bridging progress and sustainability for all. The moment to make a sustainable impact is now.
All right, let's give Sridhar a hand. And I'll hand it off to him.
Tell me about forward and backward. Excellent. All right. So, wow, it is blinding. I think it's kind of difficult to go after this big introduction about Schneider. I'm happy to see that on the big screen, and I hope you got. No? Can you advance? Oh. Technical glitches? Okay, all right. Okay, so quick introduction. I think you got the gist of it from the video. So Schneider Electric is I think one of the largest energy management companies. The joke goes internally that whenever we talk about Schneider, the first thing in North America you see is, are you a trucking company, right? I mean, we've got big trucks that are running on the highways, so we are not. And then the next one is, do you make elevators? Which is the Schindler, so we don't. So we are the energy management company. And so to give some statistics, it's about $30 billion in revenue. I think that's from 2022. About 150,000 employees and, over 100 countries that we are present. So I don't want to spend all the time giving details about the company. I want to talk about sustainability. But to give you a perspective on the diverse set of things that we do. We provide equipment and solutions to everything ranging from buildings, data centers, factories, and now a lot more getting into residential. So we've got a big initiative with the increasing number of electric vehicles, which is going to be a large load that will be placed, inside the homes. I think there is an opportunity for optimizing energy from home itself. Okay, thank you. Okay, so our purpose is really around empowering everyone to make most out of energy and resources. The sustainability purpose for Schneider has been there for a very long time before it became more and more visible and I don't want to say popular, but certainly more visible. It has really defined the purpose of everything that Schneider does. Even though we may talk about contactors and PLCs and cooling equipment, but ultimately the unifying theme for all of them is towards energy and sustainability. And electricity is the most bendable form of energy. So if you use electricity, we can provide solutions to optimize its usage and then contributing to a sustainable future. And then the next iteration on that is, so we've spent a lot of time as a company building the infrastructure to make products smarter. We have an architecture called EcoStructure, which is about the embedded devices. Then we have edge control, and then we have cloud control or analytics and apps. But a few years ago, we have taken a strategic initiative around applying AI to all these things. So I think I can associate with the previous speaker in starting and trying to find people to hire for AI. When we started, it was hard. We couldn't find people who wanted to work in a large company, even though the purpose is very clear that we want to do AI for sustainability. But I think we perceived we have great sponsorship from our execs, as well as I think the reception eventually with a market where we are about over 250 people group that is focusing on AI that is around sustainability. And I'll talk about what those areas are. So to set the context and why we talk about sustainability, AI for sustainability is two key things. One is the demand for energy is only going to grow. It's everywhere, economic, growth is obviously correlated with energy usage, and with more and more, countries, reaching the economic, potential, there is need for more energy. And secondly, the energy landscape is evolving. It's no longer just a unidirectional flow of energy coming from grid into homes or factories. We're going to have homes and factories produce their energy, buildings producing their energy, and then a mix of energy resources that are going to take us towards more sustainable and renewable energies. And they pose some unique challenges. And for example, renewables are require careful management because they don't produce on demand. The electrons don't come just in time. You have to store them, and you have to use them at the appropriate times, which means there is a lot more of optimization that is needed, anticipation and optimization that is needed to use this effectively. So we believe that AI will be a key enabler for this new energy landscape that will help us reach the sustainability goals. And this is, really the basic argument that I have for everything that we do around AI is, I know I can look at it from, the types of technologies that we use, models that we use, but ultimately it comes down to really optimizing the energy consumption and energy production. So the new energy landscape is, it's far more electric, and we see that there are going to be lots of grid-connected assets, right? So these are all the buildings that are, if you take the case of, actually I'll go to the next slide, that's a pretty good example. This is one of our buildings in France, which is a global environmental benchmark. So this is a brand new building we opened actually in 2020, and we didn't have a lot of people going to the building at that time, but now we started to see, more and more usage of it. But this is really a benchmark for using different types of energy. This is energy neutral. We've got lots of PV and wind production, and it is highly optimized with the data collection and real-time control using our homegrown microgrid technology. So we see this as an example of things that can come, buildings, of the future, which today contribute to a large part of our energy consumption. So the next part of the new energy landscape that, we start to tackle is electric vehicles. So it is no secret that the electric vehicles, are going to grow as a percentage of the overall, vehicle population. And I think last year was a dramatic one. If my memory is correct, we have over 10 million new EVs sold globally. And, almost all the existing, ICE-based, companies are transitioning. In fact, some actually making that as separate divisions, as Ford, recently did. So this introduces a very unique set of challenges. First of all, there is going to be a significant increase in the demand for electricity. But the good news is that it is also something that's that can be managed, through application of technology, right? So if you take the case of a building where you might have, vehicles coming in and charging at the same time, you have the ability to automatically decide which vehicle needs, how much charge, and you can shift the charging, across the vehicles depending upon their time of departure and depending upon the time, the energy needed, and really prevent what is called as, all these peak loads, right? Which is a common problem in the energy industry. You got to get the peak generators on, and they tend to be mostly fossil fuel and very expensive, and you really want to reduce that. And the other side of it is these electric vehicles are also going to be a great, way to store energy. With bidirectional energy exchange, you are able to manage the energy stored in that and use it, for other purposes, be it in the buildings or be it at residence. So it's a fantastic opportunity to tap into this, really gigantic battery farm, that, one can have at a building or a large storage, at home. And also optimizing its usage, because you're not going to be driving 300 miles every day, and the pattern. And we have today, algorithms. So, what you'll hear from me is that we have got a broad set of use cases. It's not just, one. So in the case of electric vehicle, we have got smart charging applications that allow either charge station operators or, fleet operators, who are going to have like, hundreds of vehicles, bus depots or, commercial vehicles, who can use this to optimize the charging, of the vehicles. The next one is in, smart grids or microgrids. So this is becoming more and more important as buildings become producers of energy and not just the consumers of energy. And a typical building, will have some kind of a renewable energy production, energy storage, and then, of course, you are connected to grid, as a primary source. And what we can do with AI is, first of all, planning and commissioning, because there is much more accurate models that you can build of the building and the usage, so you are able to install the right set of capacity, at each building. And then during the usage, there is continuous prediction and optimization, because take the case of an office building where you might have people coming in on certain days, so you can predict the patterns that people coming in. And you do know there are weekends, there are public holidays, so that automatically gives insights into how much energy this building needs. And in the case of power loss, which is not that uncommon, with the overloads, you can choose to decide which load to keep on, which load to turn off. And all of this done automatically. Right, so this is the whole point of having an artificial intelligence agent running to control this. And there is also ways that buildings can optimize. Do you want to optimize it for CO2 emissions, or do you want to optimize it only for cost? Right, because when the energy comes in, you can favor the energy that is coming in from renewable sources, or you can even favor the energy whose CO2 concentration is low, because now we do get data from providers on the CO2 concentration of electricity. So all of this really gives us tremendous power to optimize the energy consumption and reduce the carbon footprint that buildings, which are one of the largest consumers of, energy and contributing to greenhouse gas emissions. In fact, it's not, transportation. It's buildings that contribute, to a lot of GHG. So this is another application of AI from our side, and this is available through, some of the solutions that we sell, which both allow you to do the planning and commissioning, and then, run it using microgrid solutions. The other approach that we take, on the sustainability side is AI for asset management. And, this is there are a classic set of use cases, under the asset performance monitoring. But in our case, if you really focus on the assets, because our assets tend to be, really critical assets, things that if they fail, it is catastrophic, and sometimes you don't have all the redundancies that are needed. So first of all, reduce equipment failures through predictive maintenance. You don't have to go every 3 months or anything to, just to check it. We can have sensors that, understand the, patterns. We can have estimations on, aging of the equipment that we can use. The second one is, improving the uptime, because many times maintenance in the energy industry is quite complex. If you go to a substation and if you have to maintain, a medium voltage transformer, de-energizing it and then checking it, putting it back is very expensive, and it can cause disruptions. So optimizing the maintenance interventions itself contributes dramatically to improve uptime. And then extending the lifetime of the equipment. Again, this being quite a risk-averse industry, you don't want to be messing around with circuit breakers that have like 2,000 amps running through them. You essentially want to change them, replace them at regular intervals. But now with, remaining useful life estimation techniques, we can identify, for example, we can use either acoustic data, or imaging data to understand the, remaining useful life of an asset. I mean, this is through lab experiments that we do. And then let this contribute to circular economy. Either we can take the equipment and put it in somewhat of non-critical environments, or we are able to actually keep the equipment running rather than sell them new, because we are going to have, even regulations, for example, in Europe about, the need to, work on circular economy. So, I talked about all these use cases, in different domains, microgrids, electric vehicles, and, asset management. But in order to do that, it really requires thinking at very large scale, which is what, we started with, and that's been the mantra, inside the, company, is how do we adopt AI at large scale? And we've identified like 4 core pillars, of doing that. First and foremost, what is interesting is, we started here, we need like really cool algorithms, we need to know lots of data scientists, etc. But actually, the biggest challenge is having people who can identify the right use cases that, and define them with sufficient precision to convert them into, data science or machine learning problems, right? That's really the, biggest barrier. If I, send, 5 data scientists, they'll figure something to do, but is that really useful? The second one is to have a process, because we want to do things at scale. You need a process to enable, the, use cases that we have. They have the, right, magnitude of value. They can be successful. So having a right process to run things at scale. Then technology, and here I talk about, if you have to do things at scale, again, if I'm running a thermal monitoring model on a transformer, okay, there are like 10,000 transformers, so I need to have 10,000 models running, on the platform that are, getting retrained at regular intervals to make sure that their predictions are accurate, there is no data drift, etc. It's a big technology problem. So we, invest, in having the right platform to enable, running AI at scale. And lastly, people. I think having the right organization, right set of people with the right background is key. As I said earlier, it was harder at the beginning to attract the talent, but now we know that people want to work on AI that's doing useful things. Okay, no complaints about my recommendation engine on Netflix or Prime Video. Great, it does a great service, but I think using AI to reduce energy consumption, optimize electrical charging is also quite interesting and has a good purpose. So having the right set of people, and in a large company like ours, there is also a need to upskill people. It's not all going to be that we absolutely would love to hire people coming from colleges, but we also need to be training people who have spent a lot of time in the company, who understand the domain, who know the physics, who can contribute very well. So we really think at scale, for contributing to to solve this sustainability. And this will be my last slide. I'm looking at the clock, so I don't want to run over the time. So the key takeaways, for me on the sustainability side, and this is, coming from the experience of working on these problems, past couple of years, is first of all, I think the advent of new energy landscape, I think we have got, we've got to find ways to address this in a sustainable way. It's just not that, add more to it. And strongly believe that AI is a key enabler, for everything that we do in the optimized energy usage and energy infrastructure management. And lastly, we need it to be scalable. And I didn't, talk much about the trustworthiness. And we address trustworthiness from one particular angle, which is that it has to be understandable. Again, going back to my example about thermal monitoring, I know that if I want to, predict the temperature, it's generally going to depend on the load current and the ambient temperature at a minimum, right? I mean, there may be other factors. Now, if I show the model, with a large part of variability coming from these two sources, the service technician is going to believe it. If I have like a complex neural network model that I don't know what happens when it does something to you, it's very difficult to get a buy-in. So we really want to build explainable models that are understandable, and then people with domain knowledge can really start to embrace them. So that's my quick talk on the sustainability and how AI is going to contribute to that. I don't know if you have time for Q&A built in. Okay, all right. Well.
In the process portion that you mentioned in your key takeaways, where do you see the most challenge, I think, is what I'm going through. And you're going to be automating a lot of this. I noticed the trustworthy in there. So where do you think the bigger challenges are going to be compared to where Schneider Electric is right now?
So I'll talk about experience of where we were I don't know 18 months ago and where we are right now, right? So I think the first and foremost challenge was really in finding the right use cases. Everywhere, I think people have a general intuition that it is good for you, but then what specifically can you do that moves the needle? And can you it's almost like saying that ChatGPT is good for you, but okay, tell me, what use case where I can apply ChatGPT that really moves the needle. So that was one of the challenges. The second one is sticking to, the use case as a problem for too long. Because you kind of fall in love with that, the specific use case. You think that, that it may not work, but you still want to continue working on that. So killing things, stopping things is actually, much harder than one would imagine. And that's why we instituted a process where at some point you make decision to, kill things. And I think that's healthy. Any more?
Maybe just a similar question, but what's been one of the biggest challenges in terms of scaling the organization and the talent from a people perspective?
I think the big problems, I would say, so the way we started this as we got the autonomy to run this like, a small startup. It's a cliche to say that startup inside a big company. I think it looks like everyone wants to use the term, but in reality, that's exactly how we looked at it. And we got a lot of autonomy on the process. So the biggest challenge was actually figuring things out on our own. I'll tell you some, real challenges. You bring in people, a large organization. You want to make sure that you have right organizational levels, peoples with, right set of skills. You want to have a mix of experienced people and, someone, coming from outside. And it's very difficult to maintain that when you are growing fast, right? So did we make mistakes? We probably made some mistakes in, hiring like suddenly a lot of data scientists, and then we didn't have enough software engineers, who would actually build the integrations into real-world applications. And then maybe we didn't have enough data engineers because they don't always come in the exact sequence that we want. So that was one of the big challenges, in rapid growth, that we couldn't get the, the right mix at the right time that we wanted. But I think, it was really a matter of time that, we had to take time to do that. And making, people feel empowered during that time. That it's not that, they are here sitting around, waiting for, something to come, but we can actually produce something useful at this time. So it's a, it's a classic startup problem that, you have to bring in people, but then you still haven't really defined your roadmap for next, 3 years, but you still want to build people. So very similar problems. I don't know if that helps answer the question. Okay. Thank you all.
Thank you.